Gobi Desert mountain bike problem number 1, velocity. You just watched the video of our mountain bike rider taking this 2,000 foot vertical drop down a mountainside here in the Gobi Desert. So today what we want to do is we want to take a look at what might the velocity be if we disregard friction in this problem. How fast is the rider's velocity or speed as he flies down this mountainside? So you notice that the biker carried his bike or hiked his bike up the side of this mountain, and regardless of how he got to the very top, we know that the potential energy that the bike and the rider acquired is a function of the mass times acceleration due to gravity times the height that they found themselves. And if we disregard friction and the bike turns around and heads back down the mountainside, all of this potential energy is going to be converted to kinetic energy according to the law of conservation. And we know that kinetic energy can be found by calculating 1/2 mass times velocity squared. So we're going to combine these two equations to solve our problem number 1 for velocity. Again, this is frictionless velocity. We're disregarding friction. So if you recall from the video, our biker found himself somewhat in this position up here. So I'm going to go ahead and put together a little bit of a bicycle up here. And there's where our rider finds himself at the start of our video. And then his path that he chose goes through this little funnel right here. So we'll go ahead and track his path. Headed down through here a little bit, and he rode down through this section like so, across this little bit of a ridge here, and then again across this ridge, and he found himself in this position. We know that that's the distance that he traveled, and that is somewhere around 4,000 feet, so we'll say that that's 1,220 meters. Again, that is not going to be important to problem number 1. Important to problem number 1 is his vertical displacement, and vertical displacement is simply top to bottom measurement here, which we know from the video is 2,000 feet, which converts to 610 meters. So putting this all together now, I'm going to go ahead and solve this problem. We know that combining these two equations, we get mgh is equal to 1/2 mass velocity squared. We haven't talked about the mass of the rider of the bike up to this point. Probably you've noticed why by now. Mass is on both sides of the equation, so mass is going to cancel out. We're not going to have to give it any consideration right now. And as a result, our equation is gh is going to be equal to 1/2 velocity squared. And we know acceleration due to gravity is 9.8 meters per second squared. And we know that that's going to be multiplied by the height of the hill, which was 610 meters. Gets us 1/2 v squared. And to get rid of this half here, we can multiply both sides by 2. So I'm going to omit the units up at this point. So 2 times 9.8 times 610 gives us v squared. Now to get rid of, again, this exponent value up here, we're going to take the square root of both sides. So taking the square root of that will give us our velocity. And if we do our calculation here, our velocity calculates out to, now I'm going to do the calculation off screen on my calculator, comes out to approximately 109 meters per second. And if we convert that to miles per hour, a little bit more familiar velocity or speed for us, that's about 240 miles per hour. And if that sounds pretty fast, impossibly fast, you are very right. So we hope to come to the conclusion that friction here, mostly in the form of wind resistance, plays a huge factor in how fast this mountain bike can make it down the side of this mountain in the Gobi Desert.